Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of a component in which the front face, the right hand side view face and the top view face of this object, they have been combined into a 3D isometric projection over here. Now we are required to convert this 3D isometric projection into the orthographic front view, top view and right hand side view projections of this object over here. Now in order to convert this 3D isometric projection into the orthographic projections, we need to evaluate the dimensions of the front view face, the dimensions of the right hand side view face and the dimensions of the top view face over here. Now here we can check, as we are going to look at this object from the front side. So the width of the object, it will be equal to 115 millimeter. So we can check, this dimension happens to be 90 millimeter, while this dimension regarding this arc over here, this happens to be radius of 25 millimeter, while the height of this component will be equal to 62.5 millimeter. So here we know that corresponding to the straight vertical web, the height happens to be 37.5 millimeter, and corresponding to the circular portion of this vertical wave, this dimension or the radius, it happens to be equal to 25 millimeter. So that the total height of this object, it happens to be 62.5 millimeter. So the front view face, it will be mirroring width is equal to 115 millimeter and the height will be equal to 62.5 millimeter. Now when we are going to look at this object from the top, so we will observe that once again the width of the object will be 115 millimeter, while the depth of this component, it will be equal to 50 millimeter. So the top view face, it will be mirroring 115 millimeter by 50 millimeter over here. And if we are going to look at this object from the right hand side, so we will observe that the depth of the component happens to be 50 millimeter, while the height of the object will be equal to 62.5 millimeter. So the side view face of this object, it will be mirroring 50 millimeter by 62.5 millimeter. So with this information, we are required to obtain the orthographic front view, top view and right hand side view projections corresponding to this engineering object over here. So in order to obtain the orthographic projections, we know that in the first angle projections, the front view will be drawn above the XY reference line. The top view of the object will be obtained below the XY reference line, while the right hand side view projections of this object will be obtained on the left hand side of the front view over here. So here we have got XY reference line, X1, Y1 reference line over here, and we have also obtained this transfer line through which various distances alongside the depth of this object, they will be converted into the right hand side view projections over here. So now we know that the front view face corresponding to this object, it is going to measure 115 millimeters by 62.5 millimeter. So 115 millimeter happens to be the width of the solid. So here we have marked two vertical projector lines which are separated by the distance 115 millimeter, so that the width of the object will be equal to 115 millimeter into the front view projections over here. And these vertical projector lines, we have extended them into the top view projections as well, Because into the top view projections, again we are going to obtain the width of the solid equal to 115 millimeter. And we also know that the height of the solid, it happens to be 62.5 millimeter. So now at a height of 62.5 millimeter above the XY reference line, we have drawn a horizontal projector line into the front view projections, and we have extended this horizontal projector line into the right hand side view projections over here. Now we know that the top view face corresponding to this solid, it is going to measure 115 millimeter by 50 millimeter. So now we have already obtained the width of the solid is equal to 115 millimeter. Now corresponding to this depth of the solid, which happens to be equal to 50 millimeter, now we have drawn two horizontal projector lines into the top view projections, and these two projector lines, they are separated by the distance equal to 50 millimeter, so that we will be obtaining the depth of the solid is equal to 50 millimeter into the top view projections over here. And this distance of 50 millimeter of the depth, we have transferred this distance through this transfer line into the right hand side view projections as well. So now we can check, we have been able to obtain right hand side view face, which is going to measure 62.5 millimeter, it is the height, and 50 millimeter, it is going to be the depth of the solid over here. So the front view face, the top view face, and the right hand side view face of the solid, it has been obtained into the orthographic projections over here. Now we are going to locate different elements of the solid into the front view projections, into the top view projections, and into the right hand side view projections over here. Now once we are going to look at this object, we'll find that into this object, element number 1 happens to be a horizontal web over here. So we can check, this is the horizontal web, which is going to measure 115 millimeter. This will be the width of the web, and 12.5 millimeter, it is the height of the web. So at a height of 12.5 millimeter from the ground, we have marked this distance over here into the front view projections, and now we have drawn a horizontal projector line at a height of 12.5 millimeter above the XY reference line, and this horizontal projector line, we have extended it into the right hand side view projections as well. So now the height of this horizontal wave, which is going to lie onto the base of the solid, it has been obtained into the front view projections over here. Now we know that this web, it is having a circular portion towards the left hand side of this particular object over here, and this radius, it happens to be 25 millimeter over here. So now from the left hand side face of this particular solid, we have marked a distance of 25 millimeter over here, and at a distance of 25 millimeter, we can observe it is the location of a circular hole which is going to be available into the central portion of this web over here. So that is why we have marked an axis line over here. So this is an axis projector line which we have obtained into the front view projections over here. Now corresponding to this axis line, now we can check it out over here. This is the center portion corresponding to the circular hole, and it is available at a distance of 25 millimeter from the left hand side face of this particular solid. Now from the center line or the axis line, we know that we are going to have a circular hole originating from this center point over here. Now this circular hole, it is having the diameter is equal to 25 millimeter. That is, the radius will be equal to 12.5 millimeter. So now with respect to the center line or the axis line, we have marked a radius of 12.5 millimeter on either side of this axis. So now through this axis line, we have marked the location of extreme points of the diameter of the circular hole. So now two projector lines we have drawn over here in such a way that the distance between these two projector lines, this will be equal to 25 millimeter corresponding to the diameter of 25 millimeter. So this hole, it has been obtained into the front view projections over here, right? So here we are going to obtain dotted line projections corresponding to this hole over here. Now next we know that here we are going to have two more circular holes available over here into two vertical webs. So element number 2 is a vertical web. It is lying on the front side of the solid. Element number 3, it happens to be again a vertical web which is lying onto the rear side of the solid. So both these webs, they are going to have depth is equal to 12.5 millimeter each, and they are also carrying a central hole of 25 millimeter diameter, and this center or the access point of this particular hole, it is existing at a height of 37.5 millimeter from the ground and 25 millimeter from the right hand side face of this solid over here. So now we have marked a height of 37.5 millimeter from the ground over here. So now in order to locate the center point corresponding to this hole, we have marked this height 37.5 millimeter from the ground. So one center line we have marked into the front view projections over here, and this horizontal axis line, it has been extended into the right hand side view projections as well. So now we have obtained the height of this particular center point equal to 37.5 millimeter from the ground. So we know that center of this hole, it is going to lie at a distance of 25 millimeter from the right hand side face of the solid. This is going to be the right hand side face of the solid over here. So from the right hand side face of the solid, we have marked a distance of 25 millimeter towards the left hand side over here. So this will provide us the intersection of the vertical axis line and the horizontal axis line over here. So these two center lines, wherever they intersect with each other, we are going to obtain the center point corresponding to the circular hole over here into the two vertical webs. So we know that since this object happens to be symmetrical, so as the observer is going to look at this object from the front view over here, so now this circular hole which is available into the front side vertical web and the circular hole which is existing into the rear side vertical web, so both of these circular holes, they are going to overlap with each other. So now the center point corresponding to both of these holes, they have been obtained, and now with a radius of 12.5 millimeter or the diameter of 25 millimeter, we have marked a hole into the front view projections over here, and we have marked this diameter is equal to 25 millimeter. So here we have been able to obtain two circular holes overlapping with each other corresponding to the front side vertical web and corresponding to the rear side vertical web projected into the front view projections over here. Now another thing we know that once we mark this orientation of the hole into the front view projections, now we have drawn two vertical projector lines and extended them into the top view projections over here. And next we know that this distance happens to be 50 millimeter. That is, this vertical web which is lying either on the front side and onto the rear side of the solid, this vertical web, is having width is equal to 50 millimeter. Now how did we obtain this width of 50 millimeter? Because we know that this radius of the upper circular portion, it happens to be 25 millimeter. So we have been provided with this radius is equal to 25 millimeter over here. So this way the diameter of the semicircular portion, it will be equal to 50 millimeter. So we are going to obtain the distance between these two vertical edges of this vertical web, it is equal to 50 millimeter. So now we can check. We have got the right hand face of the solid. So from the right hand side face of the solid, we have marked a distance of 50 millimeter as we are going to move towards the left hand side face of the solid. And at this distance, we have marked a vertical projector line into the front view projections, and we have extended this vertical projector line into the top view projections over here. So this way, the width of this vertical web has been defined over here into the front view projections over here. So now we know that this is the width of the vertical web, and we know that through this center point has already been located earlier as we were obtaining the diameter of this hole is equal to 25 millimeter. So through the center point, we'll open the compass is equal to radius 25 millimeter, a semicircular projection corresponding to this upper portion of the vertical web. It has been obtained into the front view projections over here. Now having obtained the semicircular portion corresponding to this vertical web, now we have marked this radius is equal to 25 millimeter over here. And now we know that this vertical web, it is going to extend through this point which is at a height of 37.5 millimeter up to the top surface of the horizontal web, and this height happens to be 12.5. So this height, it will be equal to 25 millimeter on the left hand side, whereas on the right hand side this vertical distance will be extended up to the base over here. So this height will be equal to 37.5 millimeter. And now we can complete this portion, that is the portion of the horizontal web towards the left hand side orientation of the solid over here. Once we extend this projection line corresponding to the top surface of the horizontal web, so we will be able to obtain the front view projections corresponding to this horizontal portion of the web which is lying at the base of the solid over here. Now we know that there is a hole which is located in such a way that the center of this hole, it is existing at a distance of 25 millimeter from the left hand side face of the solid, and this hole is having diameter is equal to 25 millimeter. But as the observer is going to look at the solid from the front side, so this hole will not be visible to the observer. So now we will be able to obtain the hidden line projections corresponding to this hole into the front view projections over here. So we have marked this distance of 25 millimeter corresponding to the hole. So now we will see that we have obtained the dotted line or the hidden line projections corresponding to this hole into the front view projections over here. Similarly, this portion of the horizontal web, it has been covered by this vertical web which is lying in front of this horizontal web over here. So this portion of the horizontal web will not be visible to the observer. So corresponding to this portion of the horizontal web, now we are going to obtain the hidden line projections into the front view projections over here. So this way, at a height of 12.5 millimeter above the ground, corresponding to this portion of the web which has been covered by the vertical web which is lying towards the front face of the solid over here. So we are going to obtain dotted line projections into the front view projections over here. So this way, front view orthographic projections of the solid, they have been appropriately obtained. Now let us proceed to evaluate the top view projections corresponding to this particular solid. Now we know that this hole which is lying towards the left hand side portion of the solid and which is contained by the horizontal web, it is located at the center of this particular solid. That is, if the depth of the solid happens to be 50 millimeter, so we have marked a center line of this hole at a distance of 25 millimeter from the rear face of the solid, so that the center point of this hole will be located into the top view projections over here. So having located the axis corresponding to the circular hole which is lying into the horizontal web which is lying onto the base of the solid as element number 1 over here. Now we have been able to obtain the location of the circular hole having diameter is equal to 25 millimeter. So we haven't marked the diameter over here because we already know that there are going to be 3 holes and all of these holes, they are going to measure 25 millimeter each. So now we also know that these 2 vertical webs which are lying towards the right hand portion of this particular solid over here. So these vertical webs, they are having the depth is equal to 12.5 millimeter. So now at a distance of 12.5 millimeter from the rear face of the solid, we have marked this depth of the vertical web into the orthographic top view projections over here, and one horizontal projector line we have marked into the top view projections, and it has been appropriately transferred using this transfer line into the right hand side view projections over here. And now we have drawn a horizontal projector line at a distance of 12.5 millimeter from the front face of the solid, and this horizontal projector line has been transferred using this transfer line into the right hand side view projections over here. So this way we have been able to locate the position of rear side vertical web, we have been able to locate the position of front side vertical web into the top view projections over here. And now we also know that through the center point, this is my center point, through this center point there is a circular portion towards the left hand side portion of this particular horizontal web over here, and this circular portion is having radius is equal to 25 millimeter. So now with this as the center point, we will open the compass equal to 25 millimeter through the center point, and now we will be drawing an arc equal to 25 millimeter radius, so that the circular portion of the horizontal web can be located appropriately into the top view projections over here. So this way the left hand side portion of this horizontal web, it has been appropriately obtained into the top view projections over here. So now we know that the radius of this circular web, it happens to be 25 millimeter. Now as the observer is going to look at the solid from the top, so this portion of the horizontal web and this portion of the horizontal web will be visible to the observer. And another thing, we know that this portion of the web will be appearing like a rectangle in the top view projection. Similarly, this portion of the rear side vertical web, it will also be appearing as a rectangular projection over here into the top view projection. So we can check this circular portion of the rear side vertical web, it has been projected over here at the rear side of the top view projections. Now we can check the width of the vertical web, it happens to be 50 millimeter, while the depth of the web, it happens to be 12.5 millimeter. Similarly, corresponding to the front side vertical web, once again the width of this vertical web, it happens to be 50 millimeter, while the depth of this vertical web happens to be 12.5 millimeter. Now we know that there are two circular holes having diameters equal to 25 millimeter, which are available in the front vertical web and the rear vertical web respectively. So now, corresponding to this hole over here, we have drawn the vertical projector lines into the top view projections, and we will find that the projections corresponding to the circular hole having diameters equal to 25 millimeter, it will be projected as hidden line projections into the top view projections over here. So this way we have been able to obtain the top view projections corresponding to the surfaces T1. So this horizontal web surface is T1. This surface, which is corresponding to the rear side's vertical web, it happens to be T2 surface, and this element number 3, it is the vertical web which is available onto the front side of this particular object over here. So now we can check the T1 projections, they happen to be the true shape projections over here, whereas the projections T2 and T3, they happen to be apparent shape projections over here. Why? Because this is a circular portion, this is also a circular portion which is appearing like a rectangular flat projection into the top view projection over here. So that is why the projections T2 and T3, they happen to be apparent shape projections, whereas the projections T1, they happen to be true shape projections corresponding to the top surface of this horizontal web over here. Now let us proceed to evaluate right hand side view projections corresponding to this solid. Now we know that as the observer is going to look at the solid from the right hand side, so we are going to observe one rectangular projection corresponding to this front side vertical web. One rectangular projection will be available corresponding to this rear side vertical web, and one rectangular projection corresponding to this horizontal web, it will be available to the observer, as the observer is going to look at the solid from the right hand side. And besides these three rectangular projections, we know that there is one hole available over here into the front side vertical web, which is not visible to the observer from the right hand side projection view over here. Similarly, this hole which is available into the rear side vertical web, it is also not visible over here. So we are going to obtain dotted line or the hidden line projections corresponding to the circular hole which is available into the front side web. Again, hidden projections corresponding to this hole which is available into the rear side vertical web. It will be available into the vertical rectangular projections over here. So now we can check. We have drawn two horizontal projector lines through the extreme points of the diameter of this hole over here from the front view projection. So now through these horizontal projector lines, we get to know the diameter of this hole. So now corresponding to these two projector lines, we have drawn the hidden projector lines over here. So we have marked the hidden projections corresponding to this circular hole into the front side web and into the rear side web over here. Similarly, there is another hole which is available over here into the horizontal web, which is our element number 1 over here. So from the center point at a distance of 12.5 millimeter on the left side and 12.5 millimeter on the right hand side, we are going to obtain the hidden line projections or the dotted line projections corresponding to this circular hole which is available into the horizontal web over here. So now these are the projections corresponding to the circular hole which is available onto the horizontal web. And another thing we need to notice over here, that this portion of the web, that is, once we are going to move towards this particular portion of the vertical surface of the web, Similarly, once we move toward this portion of the vertical wave, so this portion, it is not visible to the observer. That is 12.5 millimeter from the front face and 12.5 millimeter from the rear face alongside this particular horizontal wave top surface. So from the front surface, similarly from the rear surface, this portion, that is the thickness of the web, so this will not be visible to the observer, as the observer is going to look at this particular vertical web number 1 and vertical web number 2 from the right hand side projections over here. So that is why one hidden projection line corresponding to the top surface, 12.5 millimeter thickness of this vertical web, this is not visible to the observer from the right hand side position. So hidden line projections will be obtained over here. Similarly, corresponding to this surface of the vertical wave, which is going to lie on the top surface of the horizontal wave, so this portion will not be visible on the other side. So again, onto the rear side also, we are going to obtain hidden line projections corresponding to this vertical surface of the web, which is going to intersect with this horizontal surface over here. So now we have been able to obtain the front view orthographic projections, the top view orthographic projections, and the right hand side view orthographic projections of the object, whose isometric projections they had been provided to us through the 3D pictorial drawing over here. So this is all for today. So we are going to continue with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lectures. So thank you very much. Thanks a lot.